Alright, hi, my name is Brian. I'm from Hamden Engineering, and today we'll be going over the RCSD-3A remote control switching demonstrator. In this video, we'll go over each of the components, how they all work with the system. We'll go over each of the 4 experiments that are outlined in the experiment manual, and how to run the LawnMaker program. First thing we'll go over is each individual part and how they work with the system. This is the main AC switch for the entire unit. Turning this on will turn on the RCSD-3A. This is where the power button is located for the computer for the RCSD-3A. These are the standard lighting panels for the RCSD-3A. They have an on and off switch on them individually and are powered through the 24-volt circuit breaker panel on the right side of the unit. So the first part of the demonstrator is the smoke detector. The smoke detector is not part of the network system. It just has an analog output that'll feed into the analog I/O modules that we'll discuss later. Alright, the next device is the thermostat. The thermostat does talk over the network with LawnMaker. The network jacks are right above it. The thermostat has 2 modes, cool and heat, and the fan output as seen below. The room temperature is displayed on the thermostat. The up and down buttons will change your set point of the thermostat to bring it into cool mode or heat mode. And the service pin for this device is by pressing the up button and the mode button together. Here we have the network relay. The network relay does talk over the network with LawnMaker. The network jacks are here on the right side. The contacts for the relay are here in the red and black terminals. Inside the cover of the relay we have the relay switch. It can be in 3 positions: on, auto, and off. Off is the relays are never in contact. On is the relay contacts are always in contact. And auto is the relay is controlled through the LawnMaker software. The service pin for the network relay is right here. Push that to put the Neuron ID into the LawnMaker software. The fire alarm does not talk over the network. It just has analog outputs that talk with the I/O modules that do talk with the network. It has an alarm output and a horn output. The alarm output and horn output a 10-volt signal that can be read through the analog modules. This is the Smart Controls analog input-output module. There are 2 devices like this on the trainer. This is module number 1. The module has 4 analog outputs and 2 digital outputs, and 4 analog inputs and 2 digital inputs. The analog outputs are 0 to 10 volts, and the analog inputs are also 0 to 10 volts. This device does talk over the network, and the service pin for this device is in the bottom left-hand corner. This is the LFAM module. It does talk over the network through the network jacks. It has 2 analog outputs, 2 analog inputs, and 2 digital outputs. The service pin for this device is right in the center. Alright, this is the wall switch. It's a 4 push button wall switch that talks over the network. Each button has its own individual output to different devices as configured through LawnMaker. The network jacks are up front, and the service pin is in the bottom right-hand corner that will have to be hit with a paperclip or screwdriver. This is the Occupancy Sensor, another device that talks over the network. The network jacks are to the right of it. It will send a signal through LawnMaker letting the program know if the surrounding area is occupied or unoccupied. The service pin for this device is in one of these holes. You'll see a black button. Just press that button. This is the DisText Scheduler. It's a device that talks over the network. This will control some of your input-output modules, when they come on, when they go off. It's also used with the thermostat in some of our experiments. The network jacks for this device are to the right of it, and the service pin can be accessed on the bottom left-hand corner. This is the emergency lighting section. These lights do not talk over the network. They are powered through an output from our I/O modules. A 0 to 10 volt signal comes in to the dimmers, which then outputs a 0 to 120 volt AC signal to the lights, which vary the brightness of the lights. This is a DC alarm. It's powered by the I/O modules. In different scenarios, it does not talk over the network. Network interface is where all of the devices talk to the network and go through to the computer. Any of the devices you want to use in the system have to be wired to these two jacks. This is this computer screen that will be used for the LawnMaker program in controlling all of the devices on the panels. It's the 24 volt DC circuit breaker panel. This is the fault panel for the RCSD-3A. Each of the faults will disrupt the system in some way. All the faults are listed in the manual as to what they turn on or off. Alright, so after you decide which experiment you're going to do from the experiment manual, you're going to wire up the RCSD-3A from the patch cord diagrams at the end of the experiment manual. Once you have the system patched up, you're going to come over to your computer, and right now we'll go over some of the things you'll do for setting up the system. So the first thing you want to do is click on User. So it'll bring you into the computer screen. LawnMaker will open automatically, and what you want to do is choose an existing network. I'm using a mouse and keyboard for this demonstration. You'll be using the touchscreen. So you're going to go into Drawing Directory and choose the drawing directory that matches the patch cord diagram and experiment you did. So if you were doing the emergency lighting program, you'd go under Hamden ELNP. So we'll do that one for an example, and you want to open the network. When this comes up, you want to enable macros. It'll come up again, enable again. Network name, server location, you want to be local, click next. You want to make sure that your network interface, click the network attached box, because we're attached to the actual network, and make sure that you're in the furthest down LAN network that you can be, and hit next. Just shows you the drawing number of the drawing. Click next. You want to make sure that you're on net in management mode, that you're connected to the network. So click that box, hit next. Everything should be registered on your computer, so you can click finish. And now you're inside the program that you are going to be using for the experiment. I'll go over how to commission and decommission a device. You'll be doing this to add or take away a component from the network. So if we want to decommission a device, you'll right click or touch and hold on one of the bottom device blocks, go to commissioning and go to decommission. It'll give you a warning about your credit points. When you decommission a device, you'll lose a credit point. It'll take away a credit point, giving you a credit point in your bank. So if you start with 25 and you decommission a device, you'll get 26 back you can use. So hit yes, click OK, and it'll decommission the device. So you can see the box turn from green to a tan color. Now if we want to commission a device, we'll right click on it, go to commissioning, commission. It'll show you which device you're going to commission. Hit next. We're going to go online, current device values, upload from device. Click next. And we're going to use the service pin to enter the Neuron ID into the system. So click the service pin and click finish. And then it'll ask you to hit this service pin on the device. So in the previous video you saw where the service pins were on each of the devices. So we're on IO Module 2. We'll hit the service pin on the lower left-hand corner and it'll commission the device to the network.